Hello everyone, this video explains Custom Physics Engine Library. The video will touch on some 3D physics library content, but it won't specifically describe 3D physics knowledge. It's merely a demonstration of the process, which developers can use as a transition to the 3D physics series. Let's first discuss why we need custom physics engine libraries. Although built-in physics engines like Box2D, Bullet, and PhysX are internationally renowned top-tier engines, some developers have specific requirements. For example, some projects don't need highly precise physics engines and only require basic physical properties or lightweight engine libraries. By customizing engine libraries, these developers can choose the most suitable engine for their projects. Examples include lightweight 2D physics engine Matter.js and lightweight 3D physics engine Cannon.js. First, let's look at the correspondence between the engine and IDE in terms of physics. For 2D, the IDE has a built-in Box2D physics engine, corresponding to the classes in the physics directory of the engine source code. In other words, in the layer IDE, after opening the project settings panel and checking the 2D physics module, you can select the 2D physics library. This corresponds to the classes in the physics directory of the layer engine source code. Similarly, there's a correspondence for 3D as well. It is built-in Bullet and PhysX physics engines, corresponding to the classes in the physics 3D directory of the engine source code. In the layer IDE project settings panel, after checking the 3D physics module, you can select the 3D physics library. This corresponds to the classes in the physics 3D directory of the layer engine source code. Whether it's 2D or 3D physics, the interfaces of third-party physics engines need to be connected one by one with layer engine interfaces. This integrates the third-party physics engine into the layer engine. Developers can ultimately use various physics engines directly through layer engine's physics interface, and visually edit them in the IDE through physics components. In other words, the physics engine that developers ultimately use is a complete physics library based on third-party physics engines and layer engine's physics interface classes, packaged together. While implementing the interface classes, Layer also completes the implementation of physics components for user-friendly visual editing. The process of connecting custom physics engine libraries is the same as built-in physics engine libraries. The only difference is that built-in engines are interfaced by the engine officials for developers and embedded in the open-source engine, while custom engines are physics engine libraries formed by project developers who understand and refer to the engine's interfacing process and interfaces, and integrate them with third-party physics engines themselves. When customizing physics engine libraries, developers need to obtain the source code or compiled engine library of the physics engine from open-source websites themselves. The layer engine physics-based library doesn't need to be rewritten by developers. They can directly use the compiled library by default. Developers only need to interface with the adaptation library of the physics engine. To help everyone better understand how to interface with third-party physics engines, we have independently open-sourced a physics engine adaptation library using the Cannon Physics Library as an example, outside of the layer engine library. This allows developers to understand the adaptation process more concisely. In the source code of this project, the SRC directory is not so complex. It only includes the code for physics engine adaptation, without the implementation of physics components. To configure the compilation environment for this project, you first need to clone the layer engine source code locally. Then update the environment dependencies of the layer engine source code by executing npm install in the root directory. Then return to the Cannon adaptation library and execute npm i2 install node modules. Create an engine path.txt file in the scripts directory and configure the absolute path of the layer engine locally. Then execute npm run update engine to compile the layer engine into the project. Finally, use npm run build to compile the physics engine into a standalone JS library file. The compiled JS library file leya.cannon.js is located in the out directory. The final JS file obtained is the Cannon Physics Engine library already adapted in the resource store. This completes the custom physics engine library. developers can place it under the Assets directory in the IDE's Resource panel. Then for the 2D Engine Library or 3D Engine Library option, first set it to Custom, then drag and drop the Custom Physics Engine Library file into the Custom Input box. This concludes the basic process of customizing engines. For more detailed content, developers can refer to the corresponding engine documentation, which has more detailed explanations. At the end of this series of tutorials, let's summarize. At the beginning of this tutorial, there was an introductory video that gave a general introduction to 2D physics. Then came the study of rigid bodies, which have three types: static rigid bodies, dynamic rigid bodies, and kinematic rigid bodies. They are the basis for simulating the physical world. Next is the collider, the layer engine, and I'd have encapsulated these colliders based on the box 2D physics engine's shapes, making them easier to understand and use. The collider base class introduced their common base class properties. Then comes the joints, which are used to connect two or more rigid bodies, constraining rigid bodies to the physical world or to each other. General functionality introduced some frequently occurring properties. After explaining these physics components, it's about their use in code. 2D physics collision events occur at different moments, and developers need to distinguish and understand the use of their parameters. Finally, this video talks about custom physics engines. Developers who need this should be clear about its development process. With this, the content of 2D physics is complete. Thank you all.